Hi everyone, once again welcome back to my channel. So today I'm going to discuss about how the history was like a shifted from basic server to containerization. Today we need to discuss on that how it evoluted from server to VM and VM to containers. We will discuss in depth in this video. So here comes going to the history in earlier 2000 we are hosting different services in the sense for e-commerce website. Take an example, we having a website and the backend we having a database basis and a lot of things we've been using for that particular e-commerce business. So basically in earlier days we are hosting a website on a different server and database on a different server. So how why we are using the different applications on different server, because we are making the architecture decoupling. uh, it helps to boost up, if something was down, then it will not affect the entire architecture. So for that purpose we are dividing that and decoupling every services and removing that dependencies. So here the server in the server we are hosting, for as I said previously, for website we are hosting one server, dedicated server, and for database we are hosting on a separate dedicated server. So here comes some advantages and some disadvantages also being there. Coming to the uh, things suppose an e-commerce website, for take an example of Amazon, it was hitting for a normal days, it was hitting only, for example we can take, it was hitting only a few, few customers, 10,000 to 20,000, for take an example like that. So that CPU and RAM and storage, it can in a particular server we having a CPU storage, and we are allocating certain resources based upon the requirement. So during that peak time, suppose it was a we predicted that and we allocated the resources, it was handling only 20,000 users. But during the peak time, that the user may increased, so the spike has been happened. So we need not to build that kind of like uh, consideration, suppose a peak time, the users may hit 30,000. So 30,000 users logging into the particular application. So but we are allocated the resources only 20,000, it was the peak of it. But during the peak time it was hitting 30,000. But what was happened in the earlier days, right? So if we taking the consideration of 30,000 users, and we designed and allocating that kind of a resources, keeping 30k users in our mind, and we are allocating that particular resources. But what about during the normal days, right? During the normal days it was not hitting at least 20,000 as well, it was hitting only 10,000 users only, maybe less. So during that time the resources may be wasted, like we are not going to use resources 100%. So it was failed in that particular cases, like it was the resources was can handle 30,000 users, but it was during the normal days, it only the users hitting to the particular website is only thousand sometimes, or 10,000, like that only. But it was wasting the resources. So for that purpose we are shifted to VM. So VM, before going to the VM, I would like to show you like how the server was hitting the peak so you can see the traditional server here. So here comes the dashboard. You can see it is a single server. So here you can see the CPU utilization, RAM allocation, and the storage. So you can see here the normal operations, most hardware resources remains idle. As I said, high electrical and real estate. overhead. This point I need to talk because when we are setting up a server, it will take some it will occupy some space because we need to place a server in a room. So it will take some space, and also we need to provide cooling system and etc etc electricity and dedicated team to support these all kind of stuff we need to consider. So and also operation cost also be high because we need to maintain the server it should available 24 by 7. So we need to make certain things to do server live. So these are the things we need to maintain while keeping a server from before hosting any application on it. So during the peak time, as I said, see, you can see the utilization of the CPU and RAM allocation and the storage. It going to be normal, but like now we can take an example of Amazon. So during the big million day, so during that sale season, it was hitting the customer drastically. It was hitting in for suppose a normal day, it was hitting only 1,000 to 10,000 maximum, but during the big billion day it was hitting more than a lakh. So how it was handling in that situation? So it basically it can't handle because it can handle only, we are allocated the resource for only 30,000 users to handle, but how it can handle 1 lakh users? So even though if was not hitting that so for suppose we are allocating considering like a 30,000 users hitting it is a peak time, but during the normal days it was not hitting that uh, like uh, not utilizing that much of resources which was utilizing in 30K during the peak time. So the resources are also wasting. We are providing the resources but it is not utilizing that, but the costing and billing was happening the 30K users when are hitting that that type of cost was hitting, and we are generating the bill on it. So it is completely waste. And from the money perspective, like revenue perspective side, we are allocating the resources and it was in idle, but the billing was happening. So this is the drawback of that server like a hosting an application. It was not utilizing the 100% of resources every time. So that is what happened during that server era phase. The utilization resources like which are being allocated to that, it was not going to be utilizing 100%. So here comes the picture. So you can see in traditional server era, you can see this is a normal scenario, and response rate is also high. You can see because it we have it is a normal during the normal traffic. It is you can see and you can also see here during the peak time hard limit reached, no auto scaling available, and severe bottleneck causes due to high user latencies. As I said, if the user has been increased, it crossed beyond the limit, then the late it will cause out of memory, and sometimes it crash, and sometimes it not going to be work. So these all kind of situation will be happen whenever it cross beyond the limit during the peak times. So you can see just hitting this. So you can see suddenly CPU utilization has been increased, RAM allocation has been increased, and storage also been drastically changed, like increased. And you can see the response rate is also decreased because the resources have been utilized like 100%. It was crossed beyond that. So the response also getting to be we are getting the response very slow. So it if it is continue like that, then the server will crash. The total the total system will not responsive for some time. So this is what happened in a traditional server era. So basically we are shifted towards VM because of that. We are not utilizing 100% of services which are provided by the server. So but the cost was generated for 100% only. We are allocated the resources, it was billing on that particular things only, even though we are using the server or not, or it in idle, it was generating the bill whatever resources we are allocated, that on that basis is what generating the bill. So the next thing is the VM. So here the VM we are talking about, like a VM in the sense is a virtual machine. Like in this virtual machine, what the difference between that a traditional server and the virtual machine is like, in virtual machine we having the main thing is we are providing the hardware and all similar kind of thing. But here comes that what was the difference between them. Here we are making on a hardware layer we are making, and for suppose a consider like this one is a hardware. So we are allocating kind of resources, the RAM and the CPU and storage. On top of it we are making like a hypervisor. Hypervisor is a kind of a tool or a service, like whatever we will calling it. Hypervisor is used to like suppose it was splitting that hardware like what we provided, the basic hardware in the sense. Suppose take an example of a 10 GB like a 16 GB RAM and 12 GB core and 20 TB SSD, like that. So on top of it we are making a kind of a hypervisor. What was the use of a hypervisor? The hypervisor is it make like it will help us to host a different kind of OS and isolated a kind of resources, and dividing and splitting the resources between them. For suppose take an example here, I consider suppose here in uh, hypervisor we can see here is the hypervisor. So here it is the host, like it was we can make like mm, take an example like that. Suppose VM1 hosting a website and VM2 hosting a database, and VM3 is like for some kind of internal things we are services we are hosting. This kind of a thing with like a hypervisor was providing. So suppose a web application was hosting in VM1. So it is that application needs a kind of a Windows OS, for suppose example, and DB database having it need to have like a host like Linux and VM3 Ubuntu. So basically there are three applications was hosting on the same resources like what we have been allocated. But the thing is hypervisor is making that OS to suitable if you want Ubuntu OS or Linux OS or Windows OS, you can host on top of it. It will provide that kind of a facility for the application. So here like what are the things happening at the time, we can allocate separate VM in the sense here a separate computer with a separate OS, separate libraries can host on that, isolating between the isolation also been happen between them. So that is what the virtualization helps. But the here the drawback is like uh, the OS having we need to waste a lot of memory for making an OS. So here you can see during the normal time here the peak time CPU utilization is high and the RAM is also high, but it can scale. So here comes you can comparison traditional server era, one physical server dedicated to one application, as we discussed previously. If the app used 5% of resources, 95% of was wasted, extremely expensive to scale and maintain. Now multiple virtual machines operating systems on one server, highly utilization but heavy overhead because every VM uh, on 1 minute. Okay, so you can see here the virtual machines like it can auto scale, but the thing is like that main disadvantage is heavy resources consumption, like a full OS for VM, slow scaling due to OS boot time, and hypervisor overhead increases with the load. Resources contain like a resource contains between VMs, like what here been discussing what they mentioned, right? So here you can see the host OS, like a hypervisor will provide the like OS. Then we can, on top of it, we can use what kind of a OS, like we can make a configure on that. So for a particular website, so here we are going to use this kind of ethics, because in single server model, like we are hosting one application for one server. Here we are hosting on one application, on three application on one server, using a virtual machine concept. So this is only one server for the, well, comparing that, this is only the one server, or on top of one server we are dividing that into three servers using a virtual machine concept. And hypervisor, we are providing a different kind of OS based upon the dependency of the each virtual machine. So that is the advantages of it, but the drawback is like it needs like whenever we are scaling, right, the OS boosting time is high. It is not that much of fast as we compare to containerization. Like we are talking the containerization in later. uh, for the sake of time, we are discussing how it was behaving during a normal time and peak time, and difference between the server and why we are going to the virtual machines. So this is the main funda behind that. Like in virtual, see, in traditional server we are hosting one application. For suppose this DB is using for 5%, and 95% resources are being wasting. So for that, the thing we are using a virtual machine concept. Here we are going to be use one server, but we are due to the with the one server using the hypervisor, we are dividing that resources into multiple parts, and that multiple parts we are making that to host to a different kinds of applications, as we here for web hosting and DB hosting, and another payment hosting, like that we can do with a suitable OS, what they need. So this is what. And coming to the containerization, what containerizations will do, like the containerization, in the sense we're talking about the image, and also we need to talk about the OS. Here in virtual machines, a kind of supervisor is providing a like it will help to host a different kind of OS for different application which was built on top of it. But here in containerization, uh, the common OS was sharing between the application. Because why? Because a different kind of a OS providing, it need like a high boost time and high time to set up. So we need to solve that problem using the container. The container will help to solve the problem, because it was hosting the single OS, and it was sharing that OS to the multiple applications. So obviously it was helpful. The boost time is also high, the latency will be low, and the thing we can spin up with less time. So this is what during here we are showing with the Kubernetes. Like Kubernetes is a kind of a orchestration tool for monitoring container services. It can make start, stop, and scaling that container services. So main difference between the virtual machine and containerization is like, yeah, containerization is a lightweight, because there is no boosting time to set up a OS for different kind of applications. But here comes the containerization will help to share the common OS for uh, like uh, stepping up that or turning on the different kind of application on particular OS. So compared to that VM, the hosting that boosting of OS time is also low, and the response is also high, and the replay also going to be the, it means the response time is also low. Low in the sense we are getting the response very speed. So when we are integrated in the Kubernetes, it will help whenever one application will down, the Kubernetes will start the another container immediately. So that kind of a stuff we will discuss in a Kubernetes. So whenever it's triggering this spike, you can see it will spin up automatically, like in the sense it was increasing its applications. Like suppose here during the normal time, you can see only web app and API services and authentic service. These are the three services or three applications just hosting. Whenever due to the high traffic, see, based upon the traffic, it again initiating the same kind of like horizontally scaling. It was like again it was creating a web service, so based upon the requirement. So these are the things we need to be considered, like in which situation we are going to be used what kind of tool or a services. So this is what I need to explain. You can see the difference, like a traditional server era and virtual machine era and modern containerization era. You can see lightweight because the shared host kernel. Because as I said, it was like we can spin up different kind of applications on the same OS. So the boosting time of OS is drastically reduced, so we can use that. And and a fast auto scaling, as I said, Kubernetes was there. It can look up like whether we can scale like based upon the load. So these are the things we need to consider, and these are the difference when we need to use a traditional server and virtual machine and container. So thank you all. Like if you having any doubt, just ping in the comment section, then we will discuss on that. So thank you all. Bye.